Part E from chapter number 2 about the interval notation. So how do we write the sets? In the previous class, in previous video lesson, we have learned that we can show some sets of numbers like integers, rational numbers, natural numbers, real numbers. Here, instead of listing all the numbers of all the elements in our set, we have some short form, short notation. It's very important when you see them in problems, you should be able to understand them. For example, there is here given a set. What does it mean? This set consists of all x's. The x's are integers and they are between -3 and 5. So how do we read this one? The set of all integers x which lies between -3 and 5, such that this line can be read as a such that x is between -3 and 5. So when you see this notation, you should understand to which number type it belongs. And this one, when you don't see equality, it between -3 and 5 not included. So we can list them if you want, so to better understand. So what they are: -2, -1, 0, 1, 2, 3, and 4. Instead of writing in the list form, there is a short form like notation is given. Okay, let's write one more. X such that let it be 10 and 1. What does it mean? The set of all natural numbers x's such that x lies between 1 and 10. So pretty straightforward notation. Let's move on and we'll solve some problems. Here's some bracket notations about inclusiveness and exclusiveness. When you see this bracket inwards, means that A and B included, and you put the equality here, and if you show them number line, the circles are usually closed. If you see the bracket is outwards, then what does it mean? B is not included, only A included. That's why we don't put equality here. And on the number line, we show as an open circle, and the number which is included is shown as a closed circle. In the same way, if A, we have the bracket which is upwards, means that A is not included, only B included. On the number line, we show in the same way. Just pay attention, be careful with the closeness of the circles. And if the both brackets look upwards, what does it mean? A and B not included. And we show with the open circles. Now, let's solve some problems from your book. For example, question number 3, again about the notation. Let's write the interval notation, the set, how it may look like, the set of all integers between -100 and 100. So my set with a curly bracket, x, it's integer, element of integers, such that x lies between 100 and -100. We close the set. So it's A. And the B, the set of all real numbers, x is real number, such that the numbers greater than 1000. So numbers greater than 1000. Just one notation of inequality. And the C, the set of all rational numbers between 2 and 3 inclusive. So x belongs to the rational numbers such that it's between 2 and 3, sorry, 3 here and 2. As it says inclusive, I need to put the equality here. So I close the curly bracket. So question number 8, also let's check question number 8. What does it say? Suppose U, universal set, x is integers between 0 and 40, and we have some sets, p factors of 28, q factors of 40, list p and q. Okay, let's do one by one. Let's list the p. What are the elements of the p factors of 28? Starting with the 1, 2, so you have to go with the numbers which divides 28 without a remainder. 4, then it goes 7, then what's next? 14, and 28 itself. And for the cube, let's list all the factors. You should always start with the 1, then it goes with 3, then it goes to 4, then it goes to 5, 8, then it goes to 10, then 20, and 40 itself. So these are the factors of 40. Now, in part B, what do we need to find? We need to find their intersection, kind of general question, which includes everything what we have learned so far. Their intersection, what do I need to do? I have to go with the elements which are in common for both of them. And do we see any similarities? So it's 1, 2, and 4, as long as 2 and 4. Yes, only 3 numbers, so I need to list them. So it's 1, 2, and 4. And for part C, find their union. If it says their union, I have to combine them. If I have repeated elements, I just list them once. So it goes 5, 7, 8, 10, 14, 20, 28, and 40. And the last but not least, D1, we need to show that just whether these numbers are correct or not, whether the left-hand side and the right-hand side are equal. These are about the numbers. Let me choose another color. So the left-hand side says the number of P union Q. So how many elements do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. I have 11 numbers there. And is it equal to the right side? My main question says it showed that. Number of P. How many elements I have in P? I have 6 numbers plus the number of Q, 8, minus their intersection number 3. Are they equal? Yes. 11 equals to 11. The left hand side and the right hand side are equal. So this one actually is also a very important property which will be used a lot in this class and in this chapter and also in probability.